on the assessment. You won't see all of it necessarily, but most of what you'll see here is going to be what you'll see on the assessment. So when you start out, you take if you're taking a full assessment, you'll start out with basic electricity first. So you'll get a basic electricity test will be the first thing that you'll start out with. So we'll go ahead and start with that. So this is going to be your sample test for basic electricity. So you'll get a 10-question sample test for basic electricity. This is pass or fail. All tests are pass or fail. You need 80% or better to pass the tests. And you need 80% or better to pass the scenarios as well, which we'll get into in a little bit. So again, there's no partial points. So even if a question has multiple answers, you need to get all the correct answers in order to get the point. I think there's really only one question on all the tests actually that I can think of that's like that. But basically 1 point per question, 10 questions on most of your tests. So obviously you've got to get 8 correct or more in order to pass. You can give us the answers in one of two ways. You can either enter the answer in the chat box, as you can see there in the example, or you can shout the answers out. So this is just to show you kind of what you'll see during the assessment. You don't actually have to put the answers in for this training. So what are the test questions that you'll see on the basic electricity? So this is one you might get. Voltage is described as what? So voltage is the pressure from an electrical circuit power source that pushes charged electrons through a conducting loop. So that's what voltage is. If you just remember voltage is pressure going through a conducting loop, then you should be good. Just remember that voltage is pressure, and B is what we're looking for on this one. Now, I do highly recommend that you guys take notes during this process. You can use notes on your actual assessment. So I do recommend that you're taking notes. So get yourself a pad of paper and a pen or pencil if you don't already have one. You can also obviously take screenshots as well. But I do recommend that you take notes because you are able to use those during the test. What I would not do during this process is write down A, B, C, or D, because that's really not going to help you. The answers are going to be jumbled around on the tests themselves. So if you're just writing down, okay, voltage is B, that's not really going to help you. You need to know the actual answer. So just keep that in mind, but you are able to use notes. You're able to use STG during the assessment. So I definitely recommend that you take notes here. All right, resistance is described as what? So resistance is going to be the measure of the opposition to current flow in an electrical circuit. So if you remember, resistance is opposition, right? It's the opposition and it's going through an electrical circuit. So your other answer on here is opposition through an insulator. We're obviously not sending electricity through an insulator. We're sending it through an electrical circuit. So just remember opposition through an electrical circuit and you won't get that one wrong. On a complete circuit, every red dot test point is going to give you what kind of voltage. So if we tag our meter from the common line to neutral, and then we take our red line and we tag each of these red dot spots on this basic circuit, what should we read? We should read 120 volts AC, right, on a common household outlet, 120 AC. Which symbol are you not going to see on a multimeter? You're not going to see pi. That's pretty obvious, right? You'll see ohms, you'll see voltage in AC, you'll see voltage in DC. You'll see current or amps, but you're not going to see pi. The total resistance is always less or more than one of the individual resistors in a parallel circuit. So parallel circuit is the key here. In a parallel circuit, an individual resistor is always going to be more than the total resistance So for the answer here we're looking for is, of course, less. So the total circuit resistance is always going to be less than any one of the individual resistors in the parallel circuit. What type of circuit is highlighted in blue? So you'll get this, and then hopefully your trainer will click one more time so you get that blue highlight there. And we're looking for parallel circuit. This is a parallel circuit. If this is your multimeter, name the 3 main basic measurements you are most likely to use on it. So what are the 3 main basic measurements you're going to take with your meter? What do you guys think? What are the three measurements you'll get from a meter? You can shout it out. You can pop it in the chat. What do you guys think? Anybody know what we're gonna use our meter for?
Voltage, amps, ohms.
Yep, there you go. Voltage, amps, and ohms. Or you can do voltage, resistance, and current. We'll take any of that. What we are not looking for is volts, AC, volts, DC, and then one of the others. Volts, AC, and DC, that's just voltage. So voltage is 1. And then, of course, ohms, and then your current or your amps. And there it is. Okay, that was weird. You guys can still see the screen okay? I think you might have lost it for a second, but it looks like it's back up. Let me know if you're not seeing my screen or if you can't hear me, guys, okay? So an amp or an ampere can be described as what? So this is an international unit used for measuring current. International unit used for measuring current. Never use neutral or chassis cabinet ground to measure DC voltages on an appliance. This is true. On a TV, that's a different story. You can use neutral or cabinet ground on a TV when you're measuring DC voltages, but on an appliance like a refrigerator, range, washer, dryer, any of that stuff, you do not want to use neutral or chassis ground when you're measuring DC voltages. There should be a DC ground on the board itself that you're going to use. So this one is true. If you test continuity on a good component with your meter, what are you going to do? What are you going to hear? Well, you're going to hear, I gave you the answer there. You're going to hear a beep, right? So if you're checking continuity and you're checking, let's say, a TCO on a microwave, and that TCO is normally closed and it's good, then it should be closed, and therefore you should hear a beep, which is telling you you've got continuity. So hear a beep. All right, and that is your basic electricity portion of your assessment. So pretty basic stuff, pretty easy. I always kind of fly through that for this training because it's pretty easy, basic stuff. So most techs usually pass that one fairly easily. Sometimes with the exception if they don't read or understand English too well, they might have a hard time, but otherwise most techs pass that pretty easily, so I usually fly through that. So once you get through your basic electricity portion, you'll move on to your laundry assessment. Now you'll notice it says laundry and dishwasher there, and that's because laundry and dishwasher are all lumped together in one RA. So if you're taking, for example, laundry, if you're doing your laundry RA only, do not be surprised when you see dishwasher stuff on there because it is all one RA. They lump it all together. So you will have dishwasher scenarios and test questions during the laundry RA portion. So just keep that in mind. Again, guys, I recommend that you take notes during this training. It'll definitely help you out during your assessment, and you are allowed to use your notes and STG as well during your assessment. So make sure you guys are taking notes. Taking screenshots, whatever you need to do. So we'll make this a little bit more interactive for the rest of this. So every now and then I'll ask you guys to jump in and try and answer some of this stuff. So don't be shy, unmute yourself and speak up or throw it in the chat. But most of it I'll still just kind of go through with you guys. So these are some of the scenarios that you may see. These are not necessarily all of them, although I will tell you that this is just about everything that we use. You're not going to get all of this during your test, of course. Generally speaking, at least as a trainer, the way I do it, and I think most trainers do it similarly, you'll usually get 2 washer scenarios, 2 dryer scenarios, and then 2 dishwasher scenarios. That'll depend on a lot of times on you guys, how quickly you're spitting the answers out, how well you're doing, things like that. If you're kind of like on the fence, or we're not really sure 100% that you have a good baseline knowledge, we might give you like an extra scenario just to kind of test you a little bit further to see what you know. But that's generally what you'll get, 2, 2, and 2. So just so you're not confused, you will see this screen when I'm giving the assessment. I don't know if the other trainers use the same format that I do, but I put this on the screen and share my screen when I'm giving you your scenarios so that you can see it in writing if you need to reference it, as well as the model numbers, which I have on there for you. So just so you're aware, because some technicians get this confused, this is not 4 scenarios here. This is 5, 6, 7, 8, 9, 10. This is 10 scenarios altogether. So each bullet point is a scenario. So you've got 3 front load washer possible scenarios that you might be tested on, 2 possible top load scenarios, 3 possible electric dryer scenarios, and 2 possible gas dryer scenarios. So each bullet point here is its own scenario. Okay, so we'll go ahead and run through a couple of these quickly for you guys. So the first one we'll go through here is front load washers violently vibrating during the spin cycles. So you got a customer that's complaining that it's vibrating and shaking really bad during spin. So what we're going to do is we're going to give you that scenario, and what we're looking for is for you to walk us through as if you were in the home, talking to the customer and then getting in front of that machine. What would you look for? What would you do? How would you troubleshoot it, etc.? So I'll run you through an example of what we're looking for that first one. So you got a customer complaining of vibration and shaking during spin. There's 2 things on every scenario that you're always going to give us. You're going to get 2 free points on these scenarios right off the bat. The first one is you want to confirm with the customer. So you're going to confirm the issue with the customer. That's the first thing always on every scenario. Why do we look for that? Because you're going to run into where you'll have on your ticket, it'll say one thing is going on, and you'll get to the home and it'll be a completely different issue. That's going to happen if you've been out there running calls already. You probably already have run into that. The tickets are wrong. That happens. So you want to confirm with the customer and make sure you're there for what you're actually there for. The next thing you're going to do is you're going to consult STG and look for service bulletins. All right, so check STG, look for service bulletins on this particular issue that you're on, and then, of course, you can pull up troubleshooting help on STG as well. So those are the first 2 things on every scenario that we're looking for from you guys, and you'll get 2 points towards your scenario score right there, basically for free, right, without even really knowing how to troubleshoot this issue. All right, so then you'll get into what are you looking for? What are you going to do? So first thing you want to check is, are there any shipping bolts left behind? So shipping bolts, if you're not sure what those are, I will show you here real quick. So shipping bolts are these guys here. These are your shipping bolts here. So this is the back of a front load washer. And those 4 guys there on the outside, those are your shipping bolts. So those go into those holes right there. You see those 4 little holes around sort of that inner outer portion there, around that back access plate. You'll have those 4 holes, and that's where those shipping bolts will go through. They'll go through those holes, screw into the back of the outer tub, and they'll secure that outer tub to the cabinet, so that when this thing is shipping, it's bouncing around inside the back of a truck, that tub inside there is not shaking around real bad and possibly getting damaged during shipping. These need to be removed as soon as this unit is installed before the customer can use it. But the unit will work with them in there, unfortunately. And sometimes installers, or if customers install them themselves, they completely miss this and they don't pull them out. So they do need to be removed. If they don't remove it and the customer uses it, it's definitely going to cause really bad vibrating and shaking. If they use it long enough, it likely will damage the inside of the unit as well. So if you find these shipping bolts inside there, you'll want to really do a good thorough physical inspection, pop this back plate off, pop the top off, and really look around, make sure nothing is damaged from those being left over. So that's the first thing you want to check, especially if it's a newer unit. If they've had the unit for 2 or 3 years, there's no way those shipping bolts will be back there because this thing would be destroyed at that point. But if it was just delivered a few days ago, a week ago, maybe even a couple of weeks ago, if they haven't used it too much, you want to check for those shipping bolts right away. All right, so after you check for your shipping bolts, you'll want to go ahead and check and make sure the unit is level. Check the floor and make sure that the floor itself isn't too pitched or too unlevel where you're not going to be able to level the unit. Check to make sure the floor is not weak, especially if it's on a second or a third floor of an apartment or like a 2-flat or a 3-flat building, or it could be a single family home that has a second floor or a third floor. Maybe they got the laundry room in their master bedroom, one of these big fancy houses somewhere. There's a good chance that floor might not be super stable. The unit will still work. It's just going to shake and vibrate a little bit more than normal in those situations. And there's not a lot if it's in a laundry room up there or a closet that obviously the units can't be moved around. Not a lot you can do about that. So check the floor. A good way to check that is if you can feel it in the floor. Like if you throw this thing on high-speed spin, it gets up to high speed and you can really feel it in your feet. Or you put your hand on the dryer next to it and you can feel the dryer shaking, vibrating, then you know there's something going on with the floor. The floor is just not quite stable. Again, make sure it's level. Check all the feet. Make sure the feet are not damaged. You want the feet screwed all the way up into the cabinet as far as it can go. So in other words, the feet should be as short as possible. And then once you get all the feet all the way into the machine, then you can start backing them out to level the unit out. And then this way your feet are as short as possible, which will make it as stable as possible. Each foot has a little locking nut on there. You want to make sure that locking nut is screwed all the way up into the cabinet to lock those feet in place. And other than that, just a good physical inspection. Popping that back access plate off, checking the motor, make sure nothing is damaged. Check especially on an older unit that's already 2-3 years old or older, that's maybe been used quite a bit. Check the wash drum itself or the wash basket. Make sure it's not wobbly. See if you can grab it, hold the outer tub still, and see if you can shake and wobble that inner basket independently of that outer tub. It shouldn't really move much at all. If it shakes and wobbles, then you probably have a cracked shaft and you got a tub job on your hands. Okay, so finally, once you've done whatever repair you need to do, you remove the shipping bolts, you leveled it, whatever you need to do, then you're going to go ahead and run a calibration mode. Calibration mode can help with vibration, so you always want to run that. No matter what, you want to run that. It kind of resets the machine. So on our washers, you want to recalibrate them whenever you're out on a call for those. And then the last thing you always want to do, and this is another free point you'll get on every scenario, any product, is you want to test the unit, you want to explain the repair to the customer and thank them. So that'll be the last thing you do. So you get 3 free points on every scenario. And that's our vibration scenario. So that's some of the things that we're looking for on that. There might be some other things that you can think of that you can throw out there at us. If it seems relevant, we'll certainly give you a point for that, even if it's not on the list that we're looking for. But those are the things that we're looking for that one. All right, we'll do a dryer scenario here too together. So we'll go through that first one under electric dryer, pretty common one. Most of us trainers are going to use this one with you. So this is probably one you'll see. No heat on an electric dryer. So again, two things right off the bat, 2 free points. You want to confirm the issue with the customer and you want to start a cycle. You want to confirm the issue with the customer and you want to check SDG for service bulletins. So again, these are the first 2 things that you want to do on every scenario. You get 2 points right off the bat right there. So for this issue, no heat, there's 2 ways you can do it, 2 schools of thought. I'm going to tell you how I did it and how I think you should do it. You might have a trainer tell you that you should reverse these 2 first things that you're going to do. But for me, the first thing you always do in a dryer call is you start the dryer up and just see what's going on. So, the customer may tell you, well, it's not heating, but that might not be the case. You might start it up, put it on a time dry, let it run 30 seconds to a minute, and you might open the door after 30 seconds to a minute, and you might feel some heat in there. So it may not be that it's not heating. It might just be that it's not getting enough heat, and this thing is just taking hours to dry. But the customers don't always explain that thoroughly, exactly what's going on. They'll just say, oh, it's not heating. It's kind of their way of saying it's not working. So you want to check for yourself. So you're going to want to throw that dryer on, run it just for about 30 seconds to a minute on time dry, and open the door and see if you're actually getting any heat. If you are getting some heat, then you're likely looking at a different issue altogether. You're looking at an airflow problem, and you want to start troubleshooting going down that road. But if you're not getting any heat, and for this scenario, we're going to tell you that you're not going to feel any heat at all, then you're going to go ahead and check the next thing, which some trainers may tell you this is the first thing you should check. That's just not how I do it, but either way, the first 2 things, you're going to test it yourself, right? And then you're going to check the outlet. So that's the next thing you're going to go to the outlet, and you're going to look for power at the outlet. So you guys think, unmute yourself or throw it in the chat box. What kind of power are we looking for at the outlet here? What kind of voltage are we looking for an electric dryer? What are you looking for at the outlet? You guys know?
240?
Yeah, you're looking for 240, right? 240 is what you want for an electric dryer. So you've got 3 legs, right? You've got 3 legs on there. Actually, let me see. Do I have a picture of that? Let me see if I have a picture. I may have a picture standby. No, I don't. Okay, never mind. Thought I had a picture. I don't. So you're looking for 240. So you're going to have an L1, you're going to have an L2, and you're going to have a neutral in the middle. So you're looking for 120 from L1 to neutral. You're looking for 120 from L2 to neutral. And then you're looking for 240 across L1 and L2. So that's what you're looking for in an electric dryer. 240, of course, is an approximation. It's not always going to be that. It's going to be, 235, might even be 220. But approximately 240 plus or minus 10% or so is what you're looking for. You really don't want anything less than, say, probably around 210. Once you get below that, then you're probably going to have some issues inside there. But yeah, 240 is what you're looking for at that outlet. So once you've done that, you turn the unit on for 30 seconds, you feel no heat, you check the outlet, your outlet is good, you've got 240 there. Next, you're going to go to the terminal block on the dryer, and you're going to look for the same thing. You're going to look for 240, L1 to L2, L1 to neutral, 120, L2 to neutral, 120. All right, you want to check it at the dryer too, because you want to make sure that power cord is sending that power through there. You could theoretically go to the terminal first if you wanted, and check it there, because obviously if the power is good at the terminal block, then the outlet is good. It just kind of depends on the situation, how easily you can get to that terminal block. If you can get to the outlet easier, then it might be just easier to check there first, because if you have a bad outlet, then you can stop right there and let the customer know. So you're going to check the terminal block next. So we're going to go ahead and say you've got good voltage there. So you checked your outlet, you checked your terminal block, you're good. Next place you're going to go is your heat relay on your main PCB. So you're going to open up your control panel, go to your main PCB, and check your heat relay there. So when you go into STG, it'll show you exactly where to connect your meter at, to look for your 120 at your heat relay to make sure you've got your power there. So why do we check for voltage? What are we looking for? If this customer says, hey, it's not heating, but the unit is working and it's spinning, why would we still need to check for voltage? Well, remember, on an electric dryer, you need 240 for that heater to run, but everything else runs on 120. The motor, the control panel, the lights, everything works on 120. So if you have 120 at L1 to neutral, but you have nothing at L2 to neutral, that unit is still going to run. The motor's going to come on, it's going to tumble. You're just not going to get any heat. So that's why we want to check for power, even if that unit is tumbling and working. You want to check that power to make sure it's correct. And you will definitely run into that. I've seen that many times where you'll go to a home and the outlet is just not wired correctly. It's wired for 120 when it's supposed to be wired for 240. So you will see that. You will definitely run into that. So you always want to check that first. And I can tell you from experience, it's going to be not a lot of fun when you neglect to check that outlet and to make sure the power is correct, and you pull that thing apart and you get inside of it and everything tests good and you're like, what the heck is going on? And then you realize, shoot, it's the outlet, and you spend an hour there for nothing. So always check that first. All right, so you got to the heat relay, that's good. So now at this point you can go ahead and go inside the dryer. So you've checked all that other stuff. Everything testing good so far to this point. Now you're going to go ahead and open the thing up and go inside. So now you're looking at your TCOs. And you'll see a picture of this when we go through the test. There's a picture in there. So I'll show you guys that here coming up in a few. But you'll go to your heater box. You'll check your TCOs. There's 2 of them on the heater box. And then there's also a TCO on the blower. But first you'll check the heater box TCOs, make sure that those are closed. Check for continuity. Obviously unplug the unit first. And then you'll check continuity at your heater coil. You'll physically look inside the heater box, make sure the heater coil looks okay. You can also take a resistance reading there as well. But generally speaking, if it has continuity, it's good to go. Especially if you take a look physically and it looks good. So once you check there, the next place you'll go is your blower. You've got 1 TCO on your blower. You also have a thermistor there, but if the thermistor pops, that unit is going to be dead, and that's a different issue. So you'll check your TCO on your blower, make sure that's good. If all those things are good, there's one more last thing you're going to check, and that's your centrifugal switch on your motor. So that I do have a picture of, and I will show you here. So your centrifugal switch on your motor looks like that. So that black piece there on your motor where your wire harness connects to is your centrifugal switch. So the centrifugal switch on a motor, what that does is when the motor starts to spin, those contacts for that switch will close. They get pulled closed through the magnetic field that's created there when that motor is running. It pulls those contacts closed, and it allows that power to go through that switch to the heater. So it's running in series with the heater. And if that centrifugal switch is stuck open, it doesn't close, that power will not get through there, and it won't go to the heater, and you won't get your 240 at the heater. And it won't heat. The unit will still run, it'll still tumble, the motor will still work. It just won't let that heating leg go through, so it won't heat. So that's the last thing you're going to check. You'll check everything else first because this is a fairly rare issue. That centrifugal switch doesn't fail too often, but it does happen. And if you've checked everything else and everything else tests good, this is likely what's going on. Okay, so again, the last thing then you'll do on every scenario is you'll test the unit. So you've replaced whatever you've replaced. Let's say the heater coils are broken, so you replace that heater box assembly with the coils. You'll put her back together. Obviously, when you're inside a dryer, always a good idea to check the rollers and make sure they're rolling smooth and all that good stuff, all that normal maintenance stuff, vacuum it out for them. You put it back together, you'll test the unit, make sure it's heating. You'll explain the repair to the customer and you'll thank them. And that'll be your last thing. All right, so that is an example dryer scenario there. So again, these are all the possible scenarios you might get. Make sure you write these down or take a screenshot if you didn't do that already. When you have a chance, go through STG, make yourself familiar with all of these issues. These are all pretty common stuff you'll see out there. And get yourself prepared for the assessment. So then after you do washers and dryers, you'll do a few dishwasher scenarios. So here are some of your dishwasher scenarios and some example models that will give you the information from these scenarios. So we'll go through one of these as well. So we'll go through that first one there, LC error code. So that's a pretty common issue, and I can almost guarantee you'll get this one on your scenario assessment test for dishwasher. So LC error code. Does anybody know what an LC or LE error code means? Anyone have any idea what's an LE or an LC error code indicate? Nobody knows? So LC or LE error code is a leak error. A leak error. And just so you guys know, C and E are interchangeable when it comes to error codes. C just stands for check code, or E obviously error code. EC is the same thing. So sometimes you'll see LC, sometimes you'll see LE. It's the same code. So LE or LC error code, and the customer cannot use the unit. That's a pretty common issue. It'll just keep flashing LE or LC, and the unit will just continuously pump because it's trying to drain the water because it thinks that it's overflowing from that leak code. So that'll be the symptom there. And that LC error code is triggered by a leak sensor, which I will show you here in a second. Actually, wait, I didn't want to do that. So your leak sensor, if you haven't seen one yet, looks something like this. Oh, there it is. So this is one of our leak sensors here. This is a 4-wire one. Some of them are 2 wires only. But this is a pretty common one. This is your leak sensor here. This is the bottom of the inside of the dishwasher. This is a little access plate that you can pop off. And you can see a little kind of reservoir section here. And this is your leak sensor. So it's essentially just 2 wires separated with 2 metal prongs underneath. You can't see them here in the picture, but there's metal prongs at the end of each of these wires. And those metal prongs, when they get connected via water, it completes the circuit, and that churn tells the board that there's water inside the unit, and you get that LE or LC error code. So these should normally be open. If you put your meter across here and they're closed, and there's probably water in here. If there's not water in here, there could be some kind of soap residue that's connecting these two together, or there might be a short inside where the wires are kind of close together and taped together. There might be a short in there somewhere where the wires are connected. But that should read open. So that's your leak sensor there. That's what that looks like. All right, so basically what we're looking for in this scenario, LE or LC error, is we want you to list off as many possibilities of where it could be leaking from and what it might be causing the leak. So to give you some examples, what are all the different possible places it may be leaking? Well, it could be leaking from all the hoses, right? There's a whole bunch of hoses in this thing, from your drain hose to your pump to drain hose, your case brake to pump hose, your case brake to drain hose. A whole bunch of hoses underneath there, so you want to check all those hoses, make sure they're not leaking, especially where they're clamped on. You want to check those spots. You want to check your sump seal, make sure that that's not leaking. Make sure your turbidity sensor, your thermistor, those all have seals. Make sure they're not leaking from those points. Your water valve connection could be leaking there. Could be leaking at the hose that goes from the water valve to the case brake, and it also could be leaking at the home connection going to the water valve as well. Even though that's on the back side of the unit, the water can roll down into the bottom of that unit and trigger that sensor as well. So a whole bunch of places you can check. What are some things that cause it? Obviously, if the hoses are broken, if where the hoses connect to things, those clamps are not tight, or something, along those lines. The unit could not be level. It could be leaning forward as opposed to being perfectly level, or even a little slight lean backwards, which is okay. So it could be unlevel, and the water could be a little bit too high in the front and pouring out the door. It could be the door seal itself. It could be an issue. Sometimes when the installers install these, they use screws that are a little too short for the side panels to connect the dishwasher at the sides to the cabinets. And they'll over tighten those short screws, and it'll actually pull the sides of the dishwasher outwards a little too hard, a little too much, and it'll actually bow that dishwasher, and it'll cause leaking at the door. So you want to check for that. Generally, you can just kind of back those screws out a little bit to loosen it, so it's not pulling so tightly, or have the customer reinstall it with some longer screws. And then, maybe the customer is using too much detergent. That's another possibility. They could be using too much rinse aid. The rinse aid thins the water so that it runs off the dishes easier. And if they're using too much, that water could be a little too thin and could be squeaking out places. So that's another possibility. So those are all the different places. You might think of a few other things. You can certainly rattle those off. But you want to rattle off as much stuff as you can think of. Don't just say a couple things and then be done. As many things as you can come up with. And then, of course, again, the last thing you want to do is explain whatever you may have repaired or replaced to the customer. We'll test the unit out, of course, and then explain the repair, and then thank them. Okay. And then there's a bunch more scenarios here, so make sure you check those out on STG. That second one, if you're not sure what NDF stands for, that's no defect found. In other words, that second scenario, what they're going to tell you is that the customer is complaining that it's not cleaning the dishes very well, but you tested the unit out and it's working fine. All the functions are working. So they're going to want to know, why would it not be cleaning if the unit itself is working? What are all the different reasons why it might not be cleaning? Okay. But yeah, check those out when you get a chance on your own, using STG, get familiar with them. So once you get through the scenarios, next you'll move to the test portion. Again, like I said, laundry and dishwasher are all one RA. So you may or may not see one test. You might see two tests, a 10-question laundry and a 10-question dishwasher. That's how we used to do it. We're kind of trying to get away from that, and using one longer test with everything all bunched into one. All right, so the first question you might see is what mode should be used in order to lessen the amount of vibration which occurs in a washing machine. So we talked about this in one of our scenarios. We talked about this in our front load washer vibration scenario. So a calibration mode is what you're going to use, which could possibly help to lessen the vibration in that unit. Calibration mode is what we're looking for there. What is the minimum water temperature required to properly operate a dishwasher? Does anybody know the answer to this? What's the minimum recommended temperature that we're looking for on a dishwasher? Anybody know? You guys are still with me? Everybody's still with me? Still listening? Still there? No, it's not 55. What's that?
100, 110, 120 Fahrenheit.
Yeah, 120. Yep, 120 is what we're looking for there. That's what we recommend. 120 is your minimum water temperature in order for that thing to clean properly. So that's what we're looking for there. That being said, I always give you guys this caveat. That's not going to be your only reason that unit is not working. So all of our dishwashers do have heaters that heat the water. And theoretically, that dishwasher should heat that water up to that minimum temperature. It's got a thermistor in there. It knows if it's not right. It won't work as efficiently if it's really cold and it's got to do all the work heating it up, but it should still do it. That being said, it's still a good idea to make sure that temp is at least pretty warm, if not hot, when it's going into the unit. So you can always advise the customer to run their sink first or turn their heater up on their water heater. But like I said, this isn't going to be the end solution. So the one thing you don't want to do is tell the customer, oh yeah, this is the reason it's not cleaning. Please run your sink first or turn your water heater up. That's not going to be the answer. It could be part of it, and you could certainly recommend that to the customer, but there's going to be other things going on inside that unit. If it is a temperature issue and that it is the only reason it's not cleaning well, then you're probably looking at something going on with the thermometer or the heater because it's not heating that water properly inside there. All right, which of these is not a component of a top load washing machine? So obviously there is no vent hose in a top load washer. What might not be so obvious to you guys if you're not sure, you haven't been inside of a front loader yet, is there is a vent hose in there. So this is your vent hose on a front load washing machine. It vents the air out through the top of the washer. It allows air pressure to relieve itself when it's spinning. It also allows air to kind of flow through there when you leave the door open in order to help dry it out when it's not being used. But our top loaders, of course, do not have that in there. All right, what is the function of a MEMS sensor? So this one, I'm going to let you guys do some homework on your own for this one. So when you get a chance, take a look in SDG, Google it, find out what is the purpose of a MEMS sensor, what does it do specifically when it comes to a Samsung washing machine, what is the purpose of the MEMS sensor? All right, smart install auto check mode on a dishwasher. How do you get into it? What is the correct sequence? So for this one, you got to be careful because a lot of technicians are going to give, they're going to go with answer D on this one. A lot of technicians will say D, and that's not correct here. That is, however, how you get into smart install diagnostic mode, which is checking for error codes. It would be D where you hit the normal key there for 7 seconds. But on an auto check mode, when you're auto checking the dishwasher, which is basically going to run it through a test cycle and check all the different functions, you're going to use that high temp wash key for 7 seconds. So we're looking for B on this one. Power on, delay start to 17H. That's all the same. Press and hold high temp. That's where the difference comes in for that auto check mode. for 7 seconds, and then you'll get your AS, and then you always press start to start the sequence. So B is what we're looking for on this one. Again, as I said earlier, make sure you guys are taking notes or taking screenshots. Just please don't write down the letter that I'm giving you guys, because that's not going to help you. It's going to completely screw you up, because these answers will be jumbled around during the actual test. So make sure you guys are not just writing down B, C, A, whatever it might be. You're actually writing the answer down for your notes, because if you're just writing the letter down, it's going to screw you up. All right, the inverter on a washer supplies power to what? What does the inverter supply power to? So on our washer, it supplies power to the motor, right? And you've got 2 halves of your motor. You've got your rotor and your stator. All right. One easy way to remember which is a rotor rotates and a stator stays. Okay. And if you're super brand new and you haven't seen those 2 parts yet, or you've seen them maybe once or twice, but you can't remember which is which, again, a rotor rotates and a stator stays is an easy way to remember. And I will show you a quick picture of those 2 things. So here you go. So that middle top picture there is your rotor, and that middle bottom picture there is your stator. So your stator has all those coils going all the way around it, and that little connection there that's kind of closest to you, sort of on the right there, is your Hall sensor and your wire harness connector. So you got your wire harness going to your stator, as well as the Hall sensor. That little black strip there is your Hall sensor, which is reading the movement of the motor. That top part there is your rotor. It has all the magnets on the inside there, and that rotates around that stator. And that stator has power going to it from the inverter. Okay, so stator is what we're looking for here, D. All right, the power supplied to a heater on a washing machine is, so a heater on a washing machine, not on a dryer, right? On a dryer, we're looking for 240. A heater on a washing machine, we're looking for 120 AC. 120 AC. All right, approximately how often should a washing machine self-clean be activated? So the answer we're looking for here is once a month. Technically, if you look in a manual for our washers, you'll see it'll say 40 or 42 loads. Every 40, 42 loads is when you want to do a self-clean. And so obviously we're not expecting customers to keep a tally sheet next to their washer of how many times they've done a load. So basically we figured out that on average, for an average size family, using their washing machine an average number of times a day, or an average number of times a month, it comes out to about once a month. So every 40, 42 loads comes out to about, on average, once a month. So once a month is what we're looking for there. How much detergent should be used on a standard load size when using a washing machine? So 2 ounces is what we're looking for there. Less is always going to be more when it comes to detergent. You want to use the least amount possible that will still keep your clothes clean and fresh. So 2 ounces is what Samsung recommends there. All right, and here's your TCOs in your heater box. I told you earlier that you'll see a picture of it coming up. So here you go. So that left picture there is your heater box on an electric dryer. Inside that box, you can kind of see it sticking out there on the right at the end. You have your heater coils, and then you've got 2 TCOs right there. You've got a normal TCO, thermostat 3, and then you've got a high limit TCO right there on the heater box. So those are the 2 first things you're going to check once you go inside the machine. When you have a no heat issue, you're going to check those TCOs there on the heater box. And then, of course, you're going to check your coils there at the terminal, the heater connections there, as well as do a physical inspection and look inside. And then your other TCO for no heat issues is on the blower, which you can see right there. TCO on the blower. And then right next to that is your thermistor. As I said during the scenarios, a thermistor is not a TCO. It's more like a fuse. So that does not count as far as how many TCOs you have. So you've got 3. 1, 2, 3. 3 is what we're looking for there. Technically speaking, there are actually 4. There is a 4th TCO. I'll show you that here. So right here, this little white part that's on that centrifugal switch part, that little white guy there with the little white wire looping around there, that's also a TCO. It's a TCO on your motor. However, we don't really count that because it's part of the motor. It's not replaceable. If that TCO were to go bad, you'd basically have a bad motor and you just have to replace the whole motor. So you could make an argument that technically there's 4, but 3 is what we're looking for here. All right, when checking a washing machine for no power, where should 120 volts AC be measured first? So again, with a no power issue, the first thing you always want to check, of course, is your wall outlet. So this is any appliance, any TV, anything you're working on. You always want to check that supply voltage first. So you're going to go to the outlet, and you're going to look for 120 at the wall outlet first. All right, when performing smart install mode on a dryer, what additional steps need to be done, which is not needed when checking washers or dishwashers? The answer is pretty much given to you there in the picture. You're going to open the door, you're going to touch the sensor bars, right? You don't have those sensor bars in a washer or a dishwasher. So obviously that's a step that needs to be done, which is not needed when checking washers or dishwashers. So you're going to open the door and you're going to touch those sensor bars to make sure that they're working during your smart install mode on a dryer. All right, so you're going to find many questions that are going to try to trip you up a little bit on this test because Samsung thought it would be fun to supply different voltages for the same parts in different dishwashers. So you got to know what dishwasher you're working on, whether it's a stainless steel tub versus a plastic tub versus possibly a water wall linear unit. All 3 of those, you're going to find different values for different parts based on what you're looking at. It can get a little confusing, so something you want to try to commit to memory. When you're working on a stainless steel tub rotary dishwasher, the power supplied from the main PCB to the water valve is going to be exactly what you would think, 120 volts AC. 120 volts AC on your stainless steel tub dishwashers. Now, next, you're going to be asked about the plastic tub dishwasher. What's the power supplied from the main PCB to the water valve on a plastic tub? So like I told you, whether you're working on a plastic tub, a stainless steel, or a water wall unit, the answers for these questions are going to differ. So what do you guys think? Anybody have any idea what the voltage is at the water valve on our plastic tub units? Does anybody know the answer to this one? Yeah, that's right, John Lee. It's 12 volts. 12 volts DC is correct. So that's what you're looking for on a plastic tub. So again, this is exclusive to the plastic tub. 12 volt DC. On our other units, it's going to be your 120 volts AC, but on the plastic tub, 12 volts DC. All right. Again, another thing that is exclusive to the plastic tub. Name the functions performed by the heater at the bottom of the tank on the Samsung plastic tub dishwasher. So, if you remember during the scenarios, I told you that all of our dishwashers have heaters and they all heat the water. All right, so all of our dishwashers have heaters and they all heat the water. However, on our plastic tub units, not only does that heater heat the water, but it also assists with drying dishes. So C heats water and assists with drying dishes on plastic tub unit. All other units, all that heater does heat the water. It doesn't dry the dishes at all. Only the plastic tub does. All right. Did I skip one? Okay. What is the purpose of a turbidity sensor in a Samsung dishwasher? So this one, guys, you guys go ahead and do a little bit of self-learning on this one as well. Take a look in STG, use Google machine, and find out what a turbidity sensor does. What is its purpose specifically on a Samsung dishwasher? What is a turbidity sensor? What is its purpose? What does it do? All right, so on your water wall linear dishwashers, the drain pump operates on a power supply of what? So again, this is exclusive to the water wall unit. All of our other units are different. Our plastic tubs are different. Our other stainless steel tubs are different. But the water wall stainless steel unit, you're looking for 40 to 90 volts AC at your drain pump on the water wall unit. So all of our other units, 120 AC, just like you would think. But on our water wall units, 40 to 90 volts AC is what you're looking for at that drain pump. All right. What is the function of the flow meter in a dishwasher? So this is another one. I'll let you guys do a little homework on this one. Check it out when you get a chance. What's the flow meter do? That's what that red arrow is pointing to. There's a little wheel with a little like impeller wheel with fins on it that spins around. It's in the case brake here on the side of the dishwasher. What does that flow meter do? What is its purpose? I'll let you guys do some homework on that one. So when you're reading a dishwasher door switch, identify normal condition of the switch and normal voltage reading at the main PCB based on if the door is open or closed. So don't worry necessarily about the wording of the question with this one. Just look at the answers and try to decide which of these answers is going to be true, because only one of them is going to be true on your dishwasher, and that is B. So what we're looking for here is B, door open, switch open, and voltage is going to be 12. So that switch will be open, so you'll be reading two separate points with your meter, which means you'll get 12 volts DC. If that switch was closed, essentially you'd be reading you'll be reading 1 point, right? Because the switch is closed on both sides of your meter, which means you're not going to get anything. You won't get a reading. So door open, switch open, voltage is 12. B is what we're looking for there. Auto release drying system on a water wall dishwasher consists of what components? What components? So what are we looking for here? Well, based on what I already told you guys about the heaters in the dishwashers, only the plastic tub heater heats the dishes, right? Or dries the dishes. So obviously on this water wall unit, the heater is not going to help dry the dishes at all. So knowing that, if you look at the answers, there really can only be one answer, right? So you're looking for C. Wax motor, actuator assembly, and blower fan. Wax motor, actuator assembly technically is really one piece. That's those two pictures up there showing you kind of cutouts of it. But when you order that, it's going to be one part. It's all going to come as one piece. But there are two separate components. Technically, you've got the wax motor, which is that little red box there. And then your actuator is the rest of that piece, all those little arms that the wax motor is going to push on, which in turn will push those little tabs at the blue arrows, which in turn will push on the door and pop it open. So you've got your wax motor actuator assembly, and then your blower fan, which is that white piece there. It looks like a speaker, and then you've got the ductwork there. That's going to go ahead and move air through your unit to help it dry. All right, and that is your laundry assessment portion. So we did your basic electricity test, and now we did your laundry/dishwasher assessment scenarios and tests. So at this point, we'll take a little break. So just a quick one, just about 5 minutes or so. You can get up and stretch, go to the bathroom, grab a cup of coffee, whatever you need to do. So we'll meet back here in about 5 minutes. I'm going to turn my camera and my sound off, and you'll hear me pop back on when we're ready to go. So take about 5 minutes, take a little break, and I'll see you guys here in a little bit.